Good morning, everyone. So my name's David. Today I'm going to tell you a little bit about HumanOps, what it is, and where it came from, and how maybe you can try and implement HumanOps principles at your own companies. So exactly 10 years ago this month, I started Server Density, April 2009. And over that 10-year period, the software I built has probably woken up tens of thousands of people. And after a couple of years, we kind of thought this wasn't really that cool. Probably many of you have been woken up in the middle of the night. You've been paged. You've got a message saying some system is broken, something is down, and you need to go and fix it. The problem is that within the technical community that we have, there is very little consideration of the long-term impacts of this kind of event. Being woken up, it's not very nice. If it's at 1 a.m., maybe you get to go back to bed and get a few hours of sleep. But there's often this kind of idea of technical operations, DevOps, sysadmins being superheroes. That's considered to be a good thing. And actually, when you think about it, you can implement systems and ideas and processes to mitigate the problems of being woken up, affecting your family, affecting your own sleep, or even just affecting the next day of work when you have to go into the office. So we came up with this idea of HumanOps, and the idea is that complicated systems are difficult. It's inherent that there are going to be problems. And sometimes when you get woken up, it does require a heroic effort. But these kind of incidents should be rare, and they should be minimized. And when it does happen, because it will, there's no such thing as 100% uptime. When these incidents happen, you should be able to use the ideas of HumanOps to mitigate those effects. And so we created a name, HumanOps, and we started a few events around the world. We got some companies in and governments to come and talk about how they do it so that we can share the best practices within the community. And really, this is about thinking about the human side of designing high availability systems, not as a separate element, but just as important as all the cool technologies, all the latest things that you deploy. The human aspect should be the same thing. Maybe UK government's not a good example anymore, but Etsy, Facebook, Spotify, and big organizations, they do this. They do this all the time. They understand that their teams are important, and they should invest in the processes to make sure that their teams are effective. So we came up with a couple of, or 4 key principles. They all link together. The first of these is quite obvious. Humans build and operate these systems, and the systems have a critical business impact. Humans require downtime. You have to sleep, you get tired, and you get stressed. And as a result of that, because those tired humans are operating critical systems, the well-being of the humans affect system operations. And as a result of that, human well-being has a direct impact on critical business systems. And it's this last point that's important because it's not just about giving people time off and having loads of sleep and not doing any work. There is actually a business case for this. Because the reason why we're waking people up is because these systems are important. They probably generate a lot of revenue. There are lots of users making use of the system. And any downtime will result in poor reputation. Downtime is caused by unreliable systems. Unhealthy teams impact reliability. And as a result, unhealthy teams mean a loss in reputation, revenue, and users. And this link is really important to make the business case for why you should implement these systems. And really, it's about human issues being the same as system issues. We have different metrics. We'll come on to metrics in a few minutes. But system issues are typically thought of as things like SLAs, uptime percentages, and response time. And you can think about human issues as being the number of times you have to manually go and fix something, or how many alerts you get in the middle of the night. And these are all things that can be measured. And so when you're thinking about the overall health of the system, it has to include the health of the humans running the system, not just the system metrics. So there's a few areas that we're going to go through about how you can actually apply these principles. So the first of these is on-call. It's where this all started. And there's a few questions you can ask internally about how you're dealing with this. So for example, how is the workload shared? When you get paged, is it just you dealing with it? And how long are you on call for? It's reasonable perhaps to expect someone to be on call for a couple of days, depending on how many times they get paged, of course. But then as the days go by, are you sharing that workload out to your colleagues? Are you on call for a week and then you're off for a period of time? At Server Density, we did this with just 6 people in the team. We had people on call for 1 week and then 6 weeks off. It's not fair to be on call for weeks and months and years. This gets easier as you have a larger company, of course, but it can still be done even in the smallest startup. And then there's things like automatic time off after an incident. It's no good waking someone up at 5 a.m., having them deal with an incident, and then expecting them to come into work and do a full day of their normal productivity. Or if they spend their Sunday fixing a system issue, why are you expecting them to come in on Monday? And then perhaps the most important thing long-term is prioritizing these issues so that when people are woken up, you understand what caused that problem, and then you prioritize it so that that's the next thing in your backlog that gets fixed. So it doesn't keep happening again and again and again. And then we talked a little bit about metrics, and this is how you can decide whether something is improving over time. Do you know what your normal level of alerting is? Really, you don't want to be getting hundreds of emails that you're just ignoring and putting into a filter. That is a poor level of baseline alerting because you're just ignoring it. But that's quite different from being woken up constantly. So understanding what the baseline is, and then over time seeing that trend down, so there are fewer and fewer alerts. It's almost impossible to get to 0, at least over a long period of time, but you can reasonably expect to only have critical incidents maybe once or twice a month, if less than that. And then so that you can make the business case for this, these metrics have to link to things like revenue, user engagement, or the net promoter score. So understanding how incidents affect the satisfaction of your users and the baseline revenue, the bottom line revenue. Documentation is something that a lot of us don't enjoy writing. It's often out of date. But this comes up when you have, particularly when you have a larger team, where the understanding of the system is not just in someone's head. As you hire more people and you're onboarding them, how do they get on board with the system? How do they know what they need to do, how things work? Checklists are a really interesting technology, something that has been used in the aviation industry for a very long time, and following a book called The Checklist Manifesto by Dr. Atul Gawande. This is also starting to be introduced into the medical industry. And the principle behind checklists is that in a highly stressful scenario, such as an engine being on fire, you don't want to have to remember the correct things to do and the right order to do them in. And you will probably know, but the stress adds an element which makes people forget or do things incorrectly. Using a checklist is a very simple way to make sure the right steps are taken and nothing is missed. And if you look at any of perhaps the older aircraft crash investigation reports, you can see how the checklists play into making the difference between a successful outcome where the aircraft and the passengers survive versus a scenario where there are no survivors. And just a couple of days ago, a 10-year study was published in the British Journal of Surgery about a large-scale trial that was done in Scotland showing how the use of checklists in surgical procedures were able to significantly reduce the number of what they call medical events, basically unwanted deaths or serious injuries resulting from surgery just caused by human error. So this can be implemented in the procedures that you follow when dealing with an incident. It can just be as simple as when you get an alert, you log into a Slack chat room, you create a Jira ticket, and you post a status update. Those are the simple things, but you'd be surprised how many people forget to do one of those things, whether it's the public status update, telling the support team, or even just creating an incident Jira ticket so you can track what's going on. Documentation also has to be up to date to be useful. The worst time to find out when something is out of date is in the middle of an incident. And so part of your QA and your testing process should really include the documentation as well. It's not just do the tests pass and can users log in or whatever the acceptance criteria is the documentation up to date as well. And just like backups, documentation is not valid unless you can actually test it and you've verified that it works. Now, alerts, this is kind of right at the beginning from where it all came from. And the key point for alerting is not that you're receiving an alert, it's that is an alert actionable? Because if you're receiving an alert from a system, what are you going to do with it? What is the point of just being told something where you don't actually have to do something? Where there's nothing for you to do, usually that scenario can be automated, so there's no need to tell a human or interrupt them. So that means all alerts that come in should be actionable, particularly if they're waking people up. The worst thing you can have is being woken up to find out that the system has recovered itself or there's nothing you can do because it's not an important alert. And this is kind of the idea behind the site reliability engineering movement or profession, which is thinking more about how you can use programming and scripting and proper formal systems to automate a lot of the operations processes so that alerts don't need to go to a human. And when they do that as a last resort, they can actually go through the system and the system can solve the problems itself. But when you do get an alert, you need to know what to do with that information. And this is kind of where the documentation comes in. And often the tool that's used is called a runbook, whether that's in the alert itself, so you just read the alert email, for example, and it tells you what you need to do, or you're copying the alert description into Wiki or some other documentation system. The idea here is that you don't have to know the system off by heart in your head to be able to resolve the problem. Does that alert contain sufficient information for you to be able to diagnose the problem and pinpoint and then fix it quickly? We've probably all seen the flood of alerts where some critical component has broken and then everything is down and you get hundreds of alerts and you've got a sudden flood and it makes it very, very difficult to diagnose and figure out exactly where that problem is. And this is where simulation comes in as well. Again, thinking about the aviation industry, the number of hours that go into training pilots in simulations of events that will probably never happen means that when, on those very small occasions where they do, the people involved know exactly what they should be doing. Not just know, it's been trained into them so that they can do it automatically. And simulation of incident response can be done in a systematic way with technical operations as well. This is about simulating a realistic outage or a problem within the system, obviously not in the real system, but in a staging environment, so that all the people who are involved in that incident response know exactly what they need to do and how they should do it. And this allows you to test things like the communication with customers, with a support team, and anyone else internally who needs to know. And also allows you to think about what you need to do if your tools are down. So this is where you think about some interesting failure scenarios of the dependencies of your systems. For example, if Like last week, Google had an outage, or like a couple of days ago, Google had an outage of their login system. The OAuth allows you to use G Suite to log into other applications. And if you're also using G Suite to log into Slack, and to log into PagerDuty, and maybe even to log into SSH, what happens when that is down, and then you have an outage? Or if all of your systems are hosted on AWS, and Slack is also hosted on AWS, what happens when you have an outage in the same zone or the region that your communication tools are also running in? The big organizations like Google do this on an extreme scale, where they switch off the entire office. For example, they've run simulations where they would completely switch off the Mountain View campus, and the rest of the offices around the world have to coordinate an incident response. That's extreme level testing of resiliency of all their systems. And it's almost like a chaos monkey for offices. It's a really interesting way of testing your redundancy and reliability. And obviously, you can build up to that. But these are the kind of things and the dependencies and things within your systems that only get found out when there's an incident. So really, the idea behind HumanOps is to provide this kind of framework so technical operations teams understand the kind of things they need to be focusing on the processes and the systems, but also making sure that the human side of infrastructure is considered in exactly the same way as the systems. Because spending money on fancy equipment, if you're buying your own equipment, or huge amounts of money on cloud environments, spending support licenses for the different software that you might be using, what is the point of doing that if you can't actually operate the system to the same level because you haven't put the same amount of thought, investment, and money into the teams that are actually running it? So that's the idea behind HumanOps. We run events around the world, and it's modeled off DevOps days. So if you're interested in running your own conference, you can take the name, you can bring people in. We've had speakers from Google, Facebook, Spotify, come in and explain how they're doing things. And the idea is to teach people and to share the ideas that the big companies have so that everybody can implement this in their own systems, so that it's not just left to technical operations to stay up all night fixing problems. And this really becomes a problem that is solved by the whole business. Thank you very much.